Okay. This class ends at 12:50, so I got maybe 20 minutes here. Okay. We'll get started in chapter 2. Okay. And chapter 2 is all, it says, the title of the chapter is called Picturing Variation with Graphs. But it's basically just, just showing how to display data, okay? Or, how, we will look at how do we display data. Okay. And so we're going to just start off with displaying numeric data. Okay. And so let's say we've gathered, we have some kind of data table, right? A data table, we have one row for each observation, okay? And so let's say, we've gathered a bunch of data, okay? Maybe we ask sex, age, height, whatever, okay? And let's just say we're going to look at the age column, okay? And so let's say we have I don't know, maybe these are 4 kids in a family. I have no idea, okay? We've decided to log all of their information, okay? And so the way a dot plot works, this is one way to display this information. We can use a dot plot. And so we've got, 4 digits, four values here, and what we're going to do is okay. All we're going to do is we're just going to put dots right at where these things are located. So 10, 12, 15, and 18. Okay. And so this kind of just shows us how spread out or how close together the values are. Okay. Let's say these were the ages in a family or something like this. Okay. And so we could also, maybe there is one of the parents, and maybe that parent is aged, I don't know, 50 or something like that, okay? If the, or, I don't know, 45 or something, okay? That, that person's age would be, way out here, and probably won't even fit on the same scale, and there'd be a dot here. And we could see, basically, that the spacing of the ages, being close together or far apart, okay? With more observations, we will have one dot for every observation. Okay? And so, you might see okay, this could be something like this could be the distribution of ages at a maybe a elementary school. Okay, this could be ages of people at an elementary school. All right, this is okay. Actually, this is probably not true, but you know, you'll have this will be like the kids' ages, the children. There's you got young kids and older kids or something, and then you probably have some adults. And over here, this is probably not true, but all of the maybe I don't know, maybe not elementary school, summer camp or something like that. Okay, at a summer camp. Okay, where they're more like camp counselors. The camp counselors will probably be very close to each other in age, right? Maybe you got kids in college or something, or not kids, but young adults who are in college, so still in a tight age range. But then there's a gap between the elementary school aged kids of this range, and then you have no one here, and then you've got some people, young adults, okay, and then maybe an older person running the camp or something, the director or something. So this would be one dot for every observation. Okay, I don't know. Does this kind of make sense? All right. So a dot plot will show us basically, and I guess an important thing is that all of these have a number line underlying it, because this is a numeric variable. There's I didn't actually draw a number line along here, or label the number line, but there's always a number line. Okay, so this will be low age values, and this will be high age values. Okay. If we were to, instead of using dots, if we put things into bars, this suddenly becomes a histogram. Okay. So if I may flip to the next slide, we have histograms. And in a histogram will look something like this. Okay, so the previous one with the different ages. Something like that, okay? You have bars rather than dots, okay? So similar to a dot plot, but bars rather than dots, okay? And so this is, again, we could have age, low, high, okay? But bars rather than dots, okay? The height of the bar represents how common that particular value is. Okay, so taller bars indicate a greater frequency of that value. Okay, histograms, we might create a frequency table of bins. Okay. Frequency table of bins or ranges. Okay, and so for example, we could say, you know, we're going to group everybody who's between 5 to 6 years old, 7 to 8 years old, 9 to 10 years old, and we'll say maybe we have a total of 6 people who are 5 and 6, and you know, 10 people and 10 people and 11 to 12, 6 people or something like that. Okay. And so we are grouping together rather than just individual ages and say there are 4 5-year-olds and 2 6-year-olds. We're going to just say kids between 5 and 6. There's a total of 6 of them together. We're grouping them together in a small range. Okay, and so you lose a little bit of the individual level of detail that existed for a dot plot. So dot plot, you have one dot for every single value, and you can trace back the exact value that that particular dot had. And with a histogram, you might lose that, especially if they bind them together. But if you've got large data sets, a histogram can be especially useful. Okay. When we have histograms, okay, we could have a histogram that looks something like this. Okay, something like that, all right? And so this indicates that what? This would be values near the middle. Values in the middle are most common. Are most frequent. And, you know, values higher, you know, much higher and much lower are much less frequent. Okay. And so just for simplicity, I'm going to just kind of draw a curve to represent this thing, and this again says values in the middle are most frequent, values that are much higher, values that are much lower are much less frequent. Okay, so the histogram can be represented with a curve. Okay, and we would call this thing unimodal, meaning one peak, and symmetric. Okay. And the symmetric there is reflecting that what happens above also happens down below. Okay, so if values get less frequent, the higher you go, then the values also become less frequent the lower you go. So that would be the symmetric aspect of this distribution. Okay, so keeping that in mind, I can have a distribution that looks like this, okay? This would be called unimodal and right skewed. Right skewed refers to this piece over here. This is known as the right tail. And the idea is, well, if you need to remember which one is right skewed or left skewed, you know, if you were to skewer some meat or something to grill, you would use the pointy end on the right side. Okay. All right. So what does it mean to be right skewed? So keep in mind we always have a number line here. So we can say something around here. We have a peak here. We got one peak, so it's unimodal. And we might say that, you know, something around here can be referred to as the, quote, middle or halfway point. Okay? So, you know, for example, if we were to try to split the total area of this shape in half, maybe we would draw it right here and say half of the area is to the left of this line and half of the area is to the right of this line. I don't know if that feels reasonable or not. Okay? So if this is the middle, to be right skewed then means that from the middle point, it is possible to have values way out here. Okay? There's not a lot of them, but we have some values. Some values exist very much higher than the middle. Okay. If I were to go this much down in the opposite direction, where would that take me? What's going on? Spin, spin, spin. Okay. So if I were to go this much in the opposite direction, oh, actually it takes me off of the paper. Okay? So if I attempt to go that distance below the middle, okay, there are no values out in that direction. Okay, the values end over here. Okay. Okay, so this is what it means to be right skewed, is that you have values that are much higher than the middle, okay, and you don't have any values in the opposite direction. Okay, so an example would be maybe annual income. Okay, I don't know. What do you think is like the typical annual income in the United States? It's like $55,000 or something like that. Okay, that's like typical, something around there. Okay, are there people that make $1 million a year? Yeah. Okay, there are people who make $1 million. There's people who make, you know, 10 million a year or more or less. Okay, so someone who makes $1 million a year is over $900,000 above average. Okay, if we were to go 900,000 below average of 55, that would take me to like negative 800 something thousand dollars. Okay, does anyone have an annual income of negative $800,000? No, that's not possible. Okay, like you cannot be legally paid a negative amount of money. So the lowest amount of money would be zero. Okay, so So this would be like 0, and this would be, you know, somewhat like $50,000, and this would be, well, according to this scale, this is like 300,000 or something, but, or 250, but, you know, you can have values much higher, but you can't have any in the opposite direction there. Okay, we'll end there for now. We'll talk more on Wednesday.